Welcome to the chemistry of life. Your turn.
Sorry, I just looked at that.
Welcome to the chemistry of life. Take home notes, part 1 by Mrs. Tolentino and
Mrs. Hood.
All right, first step. This is chapter 2. Second step, chemical reactions. Okay, first thing we want to talk about is that reactants are the things that are reacting, the two things that are combining to form a product. A product is then what is produced. Okay, if you notice here, you draw it.
Okay.
I'm not very good at the drawing. If you take a look at the double arrows, what it's trying to do is show you that a reactant, okay, is going to combine with another reactant to produce your product. But then your product can also be broken down to become your reactants again. So if you think back to the vocabulary we've talked about, a reactant, two reactants being put together is called a dehydration synthesis, and you should get water as a byproduct. And then a product, then when you break a product down, okay, when you break something down, that is called hydrolysis, and water is actually required in that reaction. You can find that on your POGL that we did.
Okay, next you have activation energy. This is the energy that is required to start a reaction. If you look at the chart in the bottom right-hand corner, or the graph, it is showing you that you have your initial state, which is your reactants. As the activation becomes to the peak, that is where your activation energy is also at its peak. And then as your final product starts to become, you have your potential energy decreased at its towards its lowest point, but not quite as low as the initial state.
Alright, there are two types of reaction. There's endothermic and exothermic. Endothermic is when energy is required. Okay, so energy has to come into the system, so it's endothermic. An example of this would be photosynthesis. Okay, exothermic then is going to be the opposite. So exothermic is when energy is released from the reaction, or it's exiting the reaction. An example of that is cellular respiration. Photosynthesis and respiration, cellular respiration, are our next unit that we will move into. Alright, next let's talk about catalysts.
Okay, catalyst is going to speed up the rate of the reaction by lowering the activation energy required. This means if you have less activation energy required, the rate at which it reacts will be greater.
Okay, catalysts are not changed during the reaction, and they can be used over and over and over and over and over and over again.
And over again.
And over again.
And over again.
And again.
Sometimes again.
And still again.
And then?
More.
Okay.
Alright, enzymes. More about enzymes. Oh wait, enzymes are organic catalysts. We just talked about catalysts in that last slide. Okay, so catalysts, remember what they do is they lower the activation energy. That's an important vocabulary word that you need to know. Activation energy, like we talked about in the last slide, is the amount of energy that's needed for a reaction to occur.
And hold on real quick. Organic, meaning containing carbon.
Wait a second, you mean organic doesn't mean alive?
Right, just that it contains carbon, and inorganic does not contain carbon.
Man, that's cool. Alright. Enzymes. You need to be prepared to always be able to identify an enzyme. If we were to give you a list of 5,000 words, okay, we wouldn't really do that, but, well, Mrs. Hood might. Yeah. If we give you a list of words, you need to be able to identify what the enzyme is, and you can do that by the ASE. That means, wow. That means that it's an enzyme. You pronounce it A's. So, there, take that.
They have a groove or a pocket where the substrates or the reactants will fit. This is called the active site. An active site fit specifically to substrates.
maybe more?
What? Yeah. Oh, yeah.
Okay. Maybe just a little more about the active site. A lot of times in science it's helpful to draw analogies or to draw examples to help you remember this stuff. An active site, if you think of an active site like a lock, okay, a lock is very specific to a certain type of key. So the keys that I have on my key set will not come unlock your door. Okay, they will not unlock Mrs. Hood's house door.
Classroom, yes, but house, no.
Yeah. Okay, because those locks are very specific to a certain shape of key. So enzymes are like a lock in that they have to have a very specific shape, or the substrate has to have a very specific shape in order for it to connect and for it to work. Okay, so there's a key.
That's a lock, thank you.
Sorry, with my drawing skills it would be a key. And
a skeleton key.
is that one supposed to be a key or is that still a lock?
It's a key.
Okay, so there's a lock and a key. So some enzymes, they need helpers. Okay, so those two types of helpers are called cofactors and coenzymes. The only difference is that cofactor is inorganic and a coenzyme is organic. So a coenzyme be things like vitamin C or any of the kinds of vitamins that you might be taking are helpful because they can help your enzymes, and your enzymes help reactions go faster. And you need reactions in order to live. Okay. Oh, look, lock and key. You're so smart.
It helps, as Mrs. Tolentino explained, it helps illustrate how enzymes function. Substrates are brought together in this process, and bonds in substrates are then weakened. Sorry, I should have read those captions.
Okay, so the bonds are weakened in the substrates, and then let's see, what do this? I should have read them too. Okay, substrates bind to an enzyme at certain places called the active sites. Okay, the enzymes, yeah, the nice arrow, I can tell that one's an arrow.
Thank you.
Nice arrows point to the active sites. Okay, it is a key. Okay, then the enzyme is going to bring those substrates together, and it's going to form a product. So if you go back to what we first started talking about, these right here are your reactants. Oh, I have really bad handwriting.
Is that a key?
Oh, that's not a V, that's an R.
Oh, okay.
Okay, so your reactants here, okay, are going to go through this reaction and then produce your product right there. And the enzyme helps to lower that activation energy so that can occur faster. Okay.
Okay, you can regulate enzyme action with temperature, pH, and a substrate or enzyme concentration. A raise in temperature will raise the reaction rate to the optimal range. If protein denatures, the reaction will stop. So if we have temperatures at a raised temp, then it'll also raise the rate at which the reaction occurs.
Within a certain range. So if you think about like an egg, if you cook an egg, what you're doing is you are raising the temperature so far out of the what's called its optimal range that it's going to start denaturing or going to start changing the shape of that enzyme. And like we talked about before, the enzyme shape is very specific to a very certain type or very certain shape for the substrate with the lock and key example.
And similar to those blocks that you play with when you're a kid where you put the certain shapes inside and they only fit, like a square won't fit into a circle.
I never had those blocks growing up.
Because your parents hated you.
Oh. All right, pH is another way that you can regulate enzyme action. There's a very narrow range that enzymes can survive in with pH. And same thing with the temperature. If you raise it out of that range, it's going to start changing its shape. It's going to denature, and the reaction's going to stop. Okay, and then last thing we have to talk about is concentration.
Yep. With concentration, the rate at which an enzyme reaction occurs can increase with an increase of the enzyme or substrate concentration. Meaning, if you have more enzymes or more substrates concentrated in an area, then that means that the reaction rate is also going to increase.
So, Mrs. Hood, what would happen if you increased the substrates to, what would happen to that rate of reaction?
If you increase the substrates,
Yeah.
then you're going to, increase it, yes.
Well, to a certain extent,
Yeah,
right?
yeah,
Okay.
and within a range.
And same is true with the enzymes. If you increase the amount of enzymes, and it's going to increase it, well, until you run out.
So similar to if you had a decrease in your amount of lactase that's in your system, which is a type of a milk product, an enzyme inside of milk, then you're no longer going to be able to digest the lactase, and then your system would start to have a lacking of that specific enzyme in your body system.
Yeah. So that's why people who are lactose intolerant, it's because they're lacking that enzyme lactase. It just means that they're not able to fully digest it.
And they get really bad gas
Yeah.
from eating it. It's really sad. Like the guy on Big Bang Theory.
Okay. And that's it. Have fun. Thanks for bearing with us.